Hello, this is the second example on the voltage and current division. We see that in this example we have 1, 2, 3, 4 resistors and no switches. So we will deal with all of these 4 resistors at the same time. Now, the questions say find Ix and Vx. Ix is the current through the 10 ohm and Vx is the voltage through the 3 ohm. He gave us the 16 volt source and 3 ampere that is going through this source. Now, if you remember the steps we talked about this, we said we have to find two resistors either in series or in parallel to apply the voltage or current division. And when I look at this circuit, I see the current is giving here 3 ampere. 3 ampere would go this way, would go to the right, and would reach this joint, right? This node. So I don't care. I don't care actually about all of this here, since I know the current is 3 ampere here. So I'm gonna write that down so you guys can remember. I don't care about this part. What I care about is to put the current which is entering here as 3 ampere, and then would name this current here and this current here. But I can see that this 3 ampere ignored this 2 ohm. It goes into that joint and would see 1, 2, 3 resistors. So this 3 ampere would split into 3 resistor, but I'm not satisfied with that. We said we have to have 2 resistors. So those 2 resistors, I would add them in series. Why? Because the current, when it goes through 2 ohm, it would continue through the 3 ohms. So those two resistors are in series. But you have to remember one thing. We said when combining resistors in series, if there is a current that is mentioned here, it would stay the same. So if I say this is I1 and then I erase those two resistors and put one resistor, I1 still go through this total resistor. But for the voltage such as Vx is named onto the 3 ohm. So when I combine those two, the Vx would disappear. The same goes with the node. So the node and the voltage in series, they would disappear. But in parallel, the voltage and the node would stay, and the current would disappear in a parallel combination. And we will discuss this more later on, but now we're concerned about the series. So this voltage would disappear. Why? Because we added those two resistors in series. So 2 plus 3 would equal to 5, and then we will redraw. We will redraw this circuit in an obvious way, but I'm gonna name the current that goes through those two resistors and this current. So I'm gonna name them I1 and Ix, since he named this as an Ix, so this is Ix. Now, if we look at this circuit, I only drew the 3 ampere because I don't care about this side. I draw 2 plus 3, which is 5, so I put here 5 with the I1, and you would notice that Vx disappeared, and then Ix. I'm asked to find Ix first, so I would go ahead and apply the current division. 3 ampere times the other resistor, which is 5, over 5 plus 10, that gives you 1 ampere. I1, which is here, equal 3 ampere times the other one, also 10 over 5 plus 10, which is 2 ampere. Now, why would I find I1 since he did not ask for I1? I named it. Why? Because I want to find Vx. The only way to find Vx is if you have I1, and then I1 would go through the 3 ohm, then I can use Ohm's law. So Vx right away would have the value of I1 times 3. So now we return to the original circuit. Vx equal I1 times 3, which is 2 times 3, 6 volt. And here we go, we found Ix and Vx. So just to conclude and to review all the questions, now always when I look to any circuit, I would try to, since he asked for IX and VX, I would try to make either two resistors in parallel or in series. If I made them in parallel, I have to have the current. That's why I did not care about the 16 volt. If I made them two resistors in series, I would be concerned about the 16 volt for that division part. But for sure, if I have two resistors in series and I know the current that goes through them, then I don't need anything else. Now stay with us for more problems. I'm gonna be covering next time a complicated problem with two current sources and couple of resistors. So stay with us.